Here's problem 838. A simple pendulum 2 meters in length is released from rest when the support string is at an angle of 25 degrees from the vertical. What is the speed of the suspended mass at the bottom of the swing? Here's our pendulum as I would look at the bottom of the swing. Here it is if it were at a 25 degree angle. So it's going to subtend through that angle along this curve like this, eventually reaching the lower height. Well, we've got these two heights. Let's call one where we start, point A, and the lower one, point B. And we're interested in this height H between the two. Well, if I look at the full length of the pendulum, that's a length L. And if I look at this triangle here, this right triangle here, the hypotenuse of that triangle is L, and the longer side is going to be L cosine theta. So the distance H that we're interested in is the difference between these two lengths. In other words, H is going to equal L minus L cosine theta, which is 2 minus 2 cosine 25 degrees, and that's equal to 0.187 meters. So that's how high point A is above point B. So let's employ the one equation to rule them all. We have that the kinetic energy at A plus potential energy at A plus any work done along the way equals the kinetic energy at B plus the potential energy at B. But we're going to define B as being our lower height, so the potential energy there is going to be 0. We started from rest, so we had no kinetic energy at point A, and there's going to be no work done along the way. We're going to assume that the air friction is 0. So we have that the potential energy at A should equal the kinetic energy at B. In other words, mgh should equal 1/2 mass velocity at B squared. Well, the m's cancel out, and solving this for the velocity at B, we have the velocity B is going to equal the square root of 2gh. We've seen this before. If we start from rest and go down to a lower height, a distance h, the velocity at that height would be the square root of 2gh. In this case, it's 2 times 9.8 times 0.187 meters is the height that we went down. All this square root, and that is equal to 1.92 meters per second. So the velocity of this pendulum at the lowest height is 1.92 meters per second.